Welcome to the 11th video in the series on electrostatics for grade 11. We're going to be doing energy of a charge in a radial field in this lesson. So we ended off here on the last lesson. So let's go to a new page. Let's consider a positive charge Q1. Okay, so let me just get that up over here. Q1 is a positive charge. So Q1 is a positive charge. Okay, consider Q1 positive charge, okay, which creates an electric field. So you can see the electric field lines there, 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 and there. Okay, and if a positive charge Q2, if Q2 is now also a positive charge, work must be done to bring this charge, because there's a repulsion between the two. So if Q2 is at infinity, very, very far away from Q1, the potential energy would be zero. But as I bring it closer and closer, there's a force of repulsion between them. And I have to do work to overcome that force. And so the closer and closer I've been, the greater the potential energy would be. So, but now in this case, it would depend on the charges on Q1 and the charge on Q2. So the formula we get for this is as follows. Let me just open up a new page. F is equal to K, Q1, Q2. Now it's not the square of the distance, it's only the distance between them. Alright, now let's go to the next page and let's consider now what would happen. Q1 is still positive, but now Q2 is negative. And obviously there's a force of attraction, and as it comes in, I have to hold it back. To take it out of that field requires work. So the formula remains the same. However, the answer is going to be negative when I go back to this formula over here. Because this one is positive and this one's negative, I'm going to end up with a negative answer. Sorry, I just see I've made a big mistake here. This is not F. My bad. It's U. P. We're talking about energy. But now the answer is going to be negative because that's positive and that's negative. If I get a negative answer, it implies, that work must be done. Work must be done to remove. Let's just use the numbers that we were using. Remove Q2 from Q1's field. So work must be done to remove Q2 from Q1's field. So that's a negative. So if they're both positive, the same amount of work will be done and the same amount of potential energy will be at all points at the same point. However, if it's a positive potential energy, it says that work must be done to bring it into the field, and if it's a negative, work must be done to remove it from the field. And that is all there is on work in a radial field. So we've done the potential energies in a uniform field, we've done the potential energies now also in the radial field.